people kind of slowed down filtering in. So why don't I get things kicked off here, and then we'll get Sam started. So, and Sam, I'm gonna probably just let you introduce yourself when the time comes. You know more about you than I do, so. Cool. All right, so let's go ahead and get started. Thanks everybody for joining us. It's already the Q1 2022 user group. That's pretty crazy. Let's see, get this going. So the user group is put on by a team of community members, the 6 of us here. We've got Bruce, Jomar, Eric, Steve, Tom, and myself. And we all kind of get together always on an annual basis, and then we kind of have at least quarterly, email exchanges to make sure that all the user group meetings are set up and scheduled, and you actually have good content. So if you ever have any tips or questions or want somebody added to the user group, we 6 are the people that you want to talk to. Obviously, you don't have to talk to all 6 of us. But whoever you're most comfortable with, just shoot us an email or find us on LinkedIn, and we'll be happy to get you connected the way you need to be connected. Obviously, the best way to get in the know about the user group is our mailing list. So this gets sent out every quarter. You get about 2, maybe 3 emails a quarter that just gives you all the information about the user group, when it's happening, the link to join us, and any announcements we have. Every once in a while, there'll be extra news, and then we'll post that as well. Or if, for example, whenever we are able to actually see each other in person again, hopefully we'll be able to actually organize some more events that would be really great to get people involved. So definitely email info@choose-mc.com if you want to be added to the mailing list. Otherwise, if you actually go to the community page on ni.com for the Minneapolis LabVIEW user group, there's also a link to join there. All right, cool. That is it for introductions. Sam is here. He's a LabVIEW champion, CLA, CPI, CTD. I will let Sam tell you what those acronyms are. And we are very happy to have you here, Sam. Thanks for joining us.
Cool, thank you. Yeah, so for anybody who doesn't know, I guess I'll start with that. CLA is Certified LabVIEW Architect. CPI is the professional instructor. And then TD is test stand developer, which basically just means I know my way around test stand. All right, let me see if I can share my screen. Let's see, window.
So there should be
now
the box with the arrow.
Yeah, I'm trying to share a screen, but it's not letting me share that one. So let me share the whole screen because that doesn't matter. Oh, you must grant permissions in order to screen share. I've got to grant myself permission.
You should be able to. Let me see what I can do here.
I am on Linux, so maybe that's my problem. Maybe I need to set up a VM and switch over to Windows. Hold on. That might be part of the problem. I don't know. Let's see if this works.
What browser are you using to?
Firefox.
Okay. Yeah, I'm using Firefox too on Windows though.
Yeah, it'll be easy to switch over. Let me. How do I do this in the full screen? Close that. Let me disconnect and reconnect on the way on there and see if that works. 1 second. Oh, oops.
It wouldn't be a video.
I think I see. Oh, I think I see. Okay.
You got muted. Can't hear you yet. Wouldn't be a video conference without technical difficulties, huh? No, can't hear you still.
I mean, that's the way to start it off right, correct? Every conference starts that way.
I think so. That's. I don't know if I've been to one where it hasn't. So. Yeah, I don't know why we lost Sam's audio. There we go. We got. Oh, Sam, if you're on a VM, do you have to pass the mic through?
This looks like it's Linux.
Oh, okay. One step at a time.
Can you hear me now?
Yes, we can.
Okay, awesome. Let's try this again. Entire screen, allow. I can't share it because I don't have permissions. Okay, now let's see. Share the screen. Let's see. Huh. Well, this is wonderful. It says share screen allowed temporarily. That's what I want. So why will that not work?
You just were sharing your screen.
Yeah, I know.
You gotta choose.
Sorry, an error has occurred when screen sharing. Well, obviously, because that's not working. All right, maybe I do need to switch over to my virtual machine and see if I can do it from Windows, because that is more likely to work. Let me try this. I'll be right back.
We can just cut this out of the recording, right?
Oh, yeah.
It reminds me of when the local radio station, they had a band playing like a live session, and then they recorded it, and then like at the beginning it was just them constantly trying to start the song and screwing up and then starting over. And it's like, when you do the recording, you're just going to cut right into the point where everybody's clapping, and they're really just excited because they finally got through the song.
Right. Yeah, so speaking of recording, Josh and Luke, we didn't actually talk about that. Are either of you recording right now?
Well, good thing I didn't start yet. You guys can hear me now?
I can hear you, yeah.
I can hear you too.
Good. All right, I'm on the virtual machine, so let's see.
I figured that Luke might not, so I started it up and it's running.
Awesome.
Thank you, Josh.
But
Thanks, Josh.
we'll see how it goes. As my
All right,
internet is latent.
All right, can everybody see my screen now?
We can, and we can hear you.
Cool. All right, I knew that would eventually work. Hold on. Oh, wait, do I have the presentation on here? And how the heck do I copy it onto the virtual machine? That is always a problem. Can I just drag and drop it? Let's see. Problems. First world problems, but all right, let's see. 1 second.
At least we have the recording of all the trolls getting started. Now we can stop the recording now that the presentation is going to start.
Yeah, that's right.
Well, I was going to say, if we want, we can actually jump into some of the code sharing and give Sam you a chance to get things worked out. If that,
Yeah, that might be a good thing. Yeah. Yeah, go
Okay.
do that for a few minutes or however long it takes you, and I'll figure this out on my end.
Assuming the rest of us don't have trouble sharing our screen.
all right, let's.
Always
I
the
will stop
optimist there.
sharing, so.
Cool. Okay, so let's see, Mr. Gilbert. You said you had one to share. Do you wanna kick us off actually?
There.
Please either say something or
Yeah. Can you hear me?
Yes.
Sorry, I was actually working.
oh.
Let's see. So now that I think about it, I've never actually bothered to share a screen.
So there's a button at the bottom of your screen that's got a rectangle with a little arrow pointing up, and you should be able to just push that.
Oh, okay.
And then if you just select your entire screen, then it'll probably prompt you to select. It'll probably give you a list of all your windows, and at the bottom of that it says entire screen.
Let's see here. Well, maybe we better do the whole screen.
We can see it.
Ha! Okay, so it's just can you see the block diagram as well?
No, just the front panel actually.
Okay, let's see if we can get that.
So you might have selected just a window instead of your entire screen.
Okay, there we go.
Now I don't feel so bad.
Well,
We're a very supportive group, Sam.
I'm happy to know that I've made someone feel better. Okay, now-
All right, yeah, that's your whole screen.
Fucking- There we go.
Great.
You see it now?
Yep.
Okay. It's just I made this years ago for applications that we use here we're using in the student labs. I think they've quit now, but just to optimize the front panel for varying monitor sizes. So it'll fill either the height or the width while maintaining an aspect ratio, which LabVIEW will sort of do, but if a lot of times if you let it expand a VI front panel to the full size of a monitor and the aspect ratio changes, the fonts get all screwed up.
Oh, sure.
So that's all it does. It's
So
not very sexy.
no, this is exactly what we're looking for. You know, these are the utility VIs that really make people's lives a lot easier. So just to kind of expand our understanding here. So this specifically resizes the window, or does it actually do certain scaling? Does it rely on any settings in this for scaling or anything?
Yeah,
like that?
I think you have to have the VI properties. It's been so long since I actually used it that, yeah, I think you have to, in the VI appearance properties or wherever it is, you have to tell it to go ahead and scale the, front panel objects.
Okay, cool. So
Yeah.
if you set the VI properties to auto scale front panel objects, and then you use this makes sure that it's actually maintaining that aspect ratio so that they
Yeah.
don't get skewed in some weird direction.
Yeah, and it'll automatically just see how big the display is and take up as much as it can without changing the aspect ratio of the front panel.
Very cool. Yeah, no, that's really useful. I think a lot of people, they just avoid that setting entirely because they don't want to deal with it. So if this solves that problem where it'll actually grow the size of things without screwing it up because you're preserving the aspect ratio, that's really useful.
And somewhere I had this, I basically tested this in a little example VI, and I'll have to find that. I just didn't, I wasn't well prepared for this, so.
No, it's all good. I'm happy that you decided to present. So great. Thanks for sharing that.
Sure.
Does anybody else have questions before we move on? Cool. All right. Thank you very much.
Sure.
Sam, are you good, or should we move on to the next one?
I'm good now if you guys are ready.
Yeah, let's do it.
Cool. All right. Let's see if this lets me share my screen, then we'll be good. All right. Can you see my slides now?
Yes, we can.
Awesome. Perfect. That'll work. Let's see. There we go. All right. So this is an introduction to unit testing. So this is kind of designed to be a little more basic. So hopefully I won't bore you guys. Let's see. Now, of course, my name is Sam Taggart. I own a company called SAS Workshops. And just a little bit about us. First thing is we believe that coding should be fun. So if you're doing something and you're not having fun, then obviously you should change that. One of the things we believe is that coding is as much a creative exercise as it is scientific. So oftentimes we think of ourselves as physicists or engineers or scientists, and we don't think of ourselves as creative. But when you're writing code and you're taking something that doesn't exist, something you've created in your mind, and you're putting it into LabVIEW software, that's a creative act. And the other part of that is we often focus a lot on the technical side, but there's a whole social side to coding as far as how we interact with other people, our peers, our coworkers, how we interact with the business that we work for, and how we interact with our users. So those things are also important. And really, it's about changing the way we think about how we write software. And we take this whole new view of writing software, and we have some universal principles that we believe in. And then we help teams develop a process that works for them, because everybody's in a slightly different situation, works for a different company in a different industry. But we believe there's some universal processes that you can apply, or universal principles that you can apply, and that you come up with a process to make coding fun and highly effective. And we do that through a variety of courses, workshops, coaching, and consulting. So if you just want to learn some new skills, we can help you with that. If you want somebody to come alongside you and help you write some code, you do that. And we also, just if you're just too busy and you want to outsource some stuff, you can do that too, and we'll help out with that. I am getting no feedback, so I can't see if anybody's reacting or whatever. So I'm going to let Will handle if he needs to interrupt me because somebody has a question. You guys can feel free to ask questions. You can throw them in the chat if you want, or you can interrupt me. That's okay. So lately, the thing that I've been focusing on most in software development is the importance of getting quick feedback. And so here I have a crossword puzzle. This is the USA Today crossword puzzle, and you can go Google and find it. And it has two modes. It has an advanced mode and a casual mode. So in advanced mode, you just type letters and you get zero feedback about whether you put in the right word or not. And so it's possible sometimes to come up with an answer to a clue that meets all the requirements. It's the right number of letters and it's related to the clue, but yeah, it's the wrong word. And so without any feedback, what happens is you start building on that wrong word, and then you end up with a bunch of wrong words. And you get to the end of the crossword puzzle sometimes, and you're like, why is it not saying I'm done? Because it looks like I filled in all the squares, and yet some of them are wrong. But there's a casual mode where when you turn that on, as soon as you type a wrong letter, you immediately get that feedback. You get that red line through it that says, hey, this is the wrong letter. And so, I mean, in crossword puzzles, right, there's like a little bit of ego involved, like, hey, I'm going to do it on the hardest mode because I'm that smart, whatever. But when we're writing code, like, we don't need to do code on expert mode, on the advanced mode. There are ways to get quick feedback and to quickly realize that, hey, I just made a typo, or I put something in the wrong case of a case structure, or I forgot some little detail. And the quicker we get that feedback, then we can fix that problem before we start building more code on top of the problem we've already created. And then things just kind of spiral and get worse. Hopefully that makes sense. So don't worry, I'm not going to tell Jeff Foxworthy jokes, but oftentimes as LabVIEW programmers, you guys come to a user group, so you might identify differently. But when I gave this presentation before was at one of the national labs, and there were a lot of people there who were technicians and scientists and physicists and engineers, but weren't really software engineers. And so if you're writing code for like a one-off thing that you're going to use just one time, and you're collecting some data from an oscilloscope, you look at it, you throw it away, then you don't really care about software engineering. But if the code you write is going to get used ever again by anybody, even yourself, then you probably should care a little bit about software engineering and about writing the code in such a way that it's going to be easy to maintain over the long term. Right? And so software engineering is not really a title or a degree, right? Because I don't have software engineer in any of my titles or degrees or anything, and I'm not computer scientist either, right? But it's a mindset, it's a way we think about things, and it's about. This is my definition. You might not find this in a textbook anywhere. I just kind of made this up. But to me, it's about developing a process and tooling around writing software. So it's more than just the act of typing, right? We're not just typists. We're not just typing code into the computer. We're actually doing the design, and we have a process for how we do that. And we have tools that help us to do that, to be more efficient at that, and help us to avoid creating problems and detect problems when we create them. And then our goal is to make software easier to deliver, change, and maintain. So when I talk about delivering software, to me, it's this idea of when I have an idea in my head, how quickly can I take that idea in my head and put it into LabVIEW code and get it working and test it and send it to the customer so that they can use it, right? Or how quickly can I get an idea that my customer has and then do that same thing? And then changing. Right. One of the great things about software, and the reason we do a lot of things in software as opposed to hardware, is that software is malleable, right? That we can easily make changes to it, much easier than, say, revising a printed circuit board, and you have to go get it printed, and it has to come back, and then you got to populate it, and then you got to test it. And right, software, we can make changes really rapidly if our software is well architected and allows for that. And then the maintenance part is, I worked for a company that made nuclear power plants. And some of the stuff there, like the minimum lifespan was like 20 years, and some of the stuff had like 50-year lifespans. So if you think about 50 years, if you start working when you're 50 or when you're 20 and you retire, you're 70, that's 50 years. So chances are, like, whoever designed this system 50 years ago has probably moved on to another company, got promoted, right? They're no longer maintaining that system. So you got to pass it off to somebody else. So part of the maintenance part is figuring out not just how do I fix bugs and how do I add features and all that stuff as the thing grows, but how do I hand it off to somebody else so that they can do that and bring in somebody who wasn't even around and may not have even been born, right? If it's a 50-year maintenance cycle on a system, 50 years later, you might hire a 30-year-old engineer. The guy wasn't even born when this system was created. So how do you bring him up to speed on this system and hand it over to him? And a lot of it goes back to being kind to the people who come after you. And that sounds great, but that's very altruistic, and it's hard to be altruistic. But hopefully everybody's motivated by at least self-interest. And so as Fab likes to say, be kind to your future self. Because often the next person who picks something up, a piece of code that you've worked on or whatever, is going to be yourself. Is everybody tracking? I'm getting like no feedback, so maybe somebody can say something just so I know I'm not talking into a black hole.
That's really good, Sam.
I hear some noise. All right, good.
Thank
you, Ryan. I recognize you. That's good. All right, so this is this picture floats around the internet, and this is actually a system that I worked on. It was the very first system that I inherited. And you look at it, right? And I'm sure, I hope, I can't see people's faces, but I hope there's some people out there cringing, right? Because we all know how painful it is to work on a system like this, right? Now, hopefully we're not creating systems like this, but they exist. And sometimes we end up inheriting them and we have to work with them. So just think about how easy it would be to make a change to this system, right? And what are all the downfalls and pitfalls of this? Because, you know, your boss is going to come to you and he's going to say, hey, we have this great project. It works. This thing was like a circuit board tester for parts or circuit boards in a nuclear power plant. It worked, right? And that's what Eli Carey says. The worst thing about code like that is it works, right? Because if it doesn't work, it's very easy to go to the boss and just say, hey, let's throw that away and start over because it's junk. But when it works, there's no throwing it away.
Can I say something
Yeah.
about it?
Okay.
So I think, well, when you see something like that, it's better to leave it alone and just start from scratch with a new program. In my opinion.
That is certainly one approach. And the younger me would have very much agreed with you, and very much, and the younger me actually very much wanted to rewrite that program, but I wasn't allowed. So that program possibly still exists. I don't know. I heard after I left, they had hired somebody like Bloomy or somebody to rewrite that for them. So I don't know what happened to that system, but it existed for like at least 10 years while I was there. So the me now tends to think that the danger of rewriting a system like that is that there's a lot of assumptions built into that code, and there's a lot of error fixes and a lot of little things that aren't obvious when looking at it from the outside. And so, you know, you could start by saying, oh, well, let's go back to the original requirements. But the truth is that whatever that does now is probably more than what the original requirements are, right? Because there's all these bug fixes and little changes that have been made, and people have come to rely on that. And so if you try to rewrite it, you're going to run into problems. So nowadays, what I tend to do with that is start refactoring it and reshaping it. And then I pick tiny little chunks off to the side and I'll rewrite one chunk at a time. And that seems to work. And one of the things I try to do is get it under some kind of test. So I have some way of verifying that as I'm making these tiny changes, I'm not breaking things. And in fact, I'm doing that actually on a project that I inherited right now. I inherited this project, and basically it's a data logger. And my first thought was, boy, I could do this all in one loop. And I inherited, and the guy had used Actor Framework and had like 20 actors. And I was like, oh my God, what the heck's going on here? And I slowly started rewriting it. And I've been able to I haven't been able to test it very well, but I've been able to iterate really quickly and get it into the hands of the people who are using it. And they're able to like report back like very quickly, like, hey, there's a problem with this or that. And I can fix it really quickly. And I've been slowly rewriting it, and now it looks a lot nicer. So yeah, I don't know. That's a really long-winded answer to your comment. So I definitely agree with the sentiment, and I definitely have had that same sentiment. I feel like I'm getting older and wiser, and I'm kind of backing off of that a little bit. But there definitely is a very high temptation to want to just throw it away and rewrite it. So, all right, that was a big tangent. But so back to the presentation a little bit. So, you know, my boss gave me this project and said, hey, we just want you to change this one thing. Right? In this case, he wanted me to change this one button color or something, right? So I said, sure, that's easy, right? I go in, I open up the front panel, I, you know, hit the paint tool or whatever the little paintbrush tool is, paint the different color, save it, rebuild the executable. I was dumb. I was young. I didn't even bother testing it. I just sent it back and said, here you go. It works. It should work. You know, because I was like, this is such a dumb, stupid task, right? And they ran and they said, no, it didn't work. And I was like, really? And basically they were setting all the button colors by like the name of the control and some far off VI, you know, they were using VI server to get all the names of the controls and set all the button colors. And so I learned a lot right there and was very humbled. But here's the thing, right? When your boss says just add this one feature, he's only looking at a tiny part of the problem, right? He's looking at the user interface. He's saying, well, you got a button and somewhere there's a thing that tells you what color it is. It should be very easy to just change that one thing and change the color. Right? He's just seeing the tip of the iceberg. He doesn't see the huge massive code that's behind that and how tangled it is and everything. We as developers see that, but he doesn't. But if you flip it around, right, when you hear your boss say, just add this one feature, we're only seeing the tip of the iceberg because that request is actually very loaded. Because if he says change the color of that button and you change the color of the button, but everything else in the program breaks, he's not going to be very happy, right? Because there's implied in his question, in his request, is change this one thing, but don't break the other 99% of the program. And I got that out of the Michael Feathers book, and that was really eye-opening to me because, like, most of the job of working with a legacy code base is not breaking all the existing features. And I mean, if we go back to this house of cards, right? Painting what, like, it blows my mind to think that whoever wrote this actually got to work to begin with. Because I just think, like, man, I would change one thing here and, like, it would have drastic consequences. I had no idea what's going on. And so that's kind of this weird dichotomy that we're only seeing the tip of the iceberg when I ask that question. So how do we make sure that we don't break all the existing features? And this right here is a project that I worked on. It's just a little project, but this is our end goal and what we want to have. And I'm going to play this video and hopefully you guys can see this. But what we want to be able to do is, you know, our boss gives us this thing. We check out the project. The first thing we do is we press one button and it runs a whole series of tests to tell us that, hey, you know, the code works. So our starting point is the code works. Then we would add one or two tests that test the functionality that we want to add, right? And of course they'll fail because, you know, we haven't added that yet. But then as we're adding this stuff, we can keep running these tests and it will tell us if we broke something and it will tell us when we're done, because when all the tests pass, including the ones for the feature that we're adding, then we know that we're done and we know that it works. Right? And so this is kind of like the end ultimate goal. It's really hard to get from that legacy code to this. But when we write new projects, when we create new projects, when we write new code, we can start adding tests so that eventually someday we get to this point. And the tests are really just there to give us that, like, warm, fuzzy feeling that, yeah, we probably didn't break anything. You can never catch everything with the unit test, but it gives you a really good feeling. So
I definitely see the value to unit test and especially regression testing. One of the advantages I see of LabVIEW over other languages is that it's easier to at least manually do unit tests quite often because you got the front panel right there. You just throw the values in and see if it works, kind of thing. It's amazing how many times you can find that it doesn't add the two numbers like you thought it did. Or whatever simple thing just by throwing some numbers in the front panel. But the one objection I've always had to, or the one downside, I guess, of unit testing is you generate code typically to do the testing. Like, for instance, you need data in the right format or the right mathematical relationships as input to your VI. And so then you write something to generate simulated data. And next thing you know, you've got more bugs in your test code than you do in the code you're testing. And so you're kind of adding effort. I mean, in the long run, if you do many changes and you do a lot of regression, it's always going to pay off. But it's really hard to get yourself to write the unit tests as you're going because you think, well, once it's working, I'm not going to touch it again, or, you know, whatever you think. And like I say, you're kind of somewhat, to first approximation, you're doubling the amount of code you're writing or close to it. I don't know what your thoughts are on that.
Yeah. So I have a couple comments on that. We are going to address that a little bit later. So we're definitely going to talk about that. So let me see. Your first point was that it can be difficult to generate the test cases, right? The code, the numbers that you're putting into your VI to make sure it's right. That I would say that if your test is really complicated, has a bunch of logic in it, we want to avoid that. So you want to have just constants in your test. So, like, You know, a lot of times I've seen things where like, you know, you're doing some calculation, and a lot of times the paper or whatever that has the calculation will have a couple test cases right in the paper, right? So it'll say, hey, here's our data, and here's the formula that we came up with, and here's the data that supports that. And you can just pick a few points out of that data. So you're not actually calculating anything. You can put them down as constants. So that was the first part. And then there's something else. What was the last thing you were commenting on? Because I kind of lost my train of thought there with that.
Well, just that sometimes you spend as much effort in generating and debugging the test code as the code itself.
Okay, so first of all, if you keep the test code simple, then you spend less time debugging the test code. But there's a very good video, and I'm going to link it at the end. And it's this weird paradox. So yes, you do spend more time writing code, but, and this video is called the lump of code fallacy. A lot of what you do is not actually writing code. A lot of what you do is reading code. A lot of what you do is running code to see what the results are. There's a lot of time spent in front of the keyboard and sitting in the computer, but that aren't actually writing new code. And what happens is, yes, the time you spend writing code increases, but the time that you spend doing all those other activities decreases more than what you increase writing the code or writing the extra tests. And so, you know, one of the biggest things I found from doing unit testing, particularly test-driven development where you write the test first, is that I basically spend no time debugging. Like I break my work down into really small steps, and I write a test first, and I start writing code. And when I think I'm done, I run the test. And if it fails, I spend about 30 seconds looking at my code for something obvious. And if I can't find it, I throw that away. I go to get, and I say get reset, throw it away, and start over. Because a lot of the bug problem is tracking down the bug takes a lot of time. Fixing the bug is usually easy once I find it, but tracking it down takes a lot of time. And so if I break my work down really small and it's only like 5 or 10 minutes of work, it's easier to just throw that work away and start over. And I end up saving a ton of time because I could spend 20 minutes or half an hour digging through my code to try to find the bug and then fix it, or I could throw away 5 minutes of work and redo it. And that is a huge savings. So just like the thing it says in the video that I'll link at the end is just like observe as you're going through your day, how much of your time are you actually writing code and how much time are you spending chasing down bugs? How much time are you spending running code to, you know, putting stuff in the front panel to see what it does, to verify things and doing that kind of debugging? And I think you'll be surprised at how much time you spend doing that. And then imagine if you didn't have to do that, how much time would you save? And I think that's where unit testing really comes to the forefront and pays for itself. So hopefully that answers your question.
Interesting idea of writing the test first. I don't think I've ever done that. That I want to try that. But and again, there are advantages to unit testing, but the test code, it's not just a matter of writing the test code. That code also has to be debugged. I mean, I've had situations where I write a VI and then I write the test code, and then I run it and it shows that there's a bug, and I sit there wasting time on my routine, assuming that's where the bug is, and actually the bug was in the tester. You know, so it.
Yeah. So that signifies, I think, that your test code is too complicated. So having really complicated test code with a lot of logic does run into that problem. And so when we get to that point, hopefully you'll see that the tests that I'm going to show you here are actually really very simple. And so if you get in a situation where you've got a lot of setup stuff in order to get everything correct before you run the test, the payoff on that is probably low. And so what I recommend then is trying to test smaller pieces. It probably says you're trying to test too much of your code at once because you've got all these setup things that you have to do before you can test the thing. So that would be what my advice would be to think a little smaller on what you're testing. So, yeah. So I'm happy to continue this conversation later, but we should probably get moving so I don't run out of time. So another reason to write tests, and this kind of goes to what we were just talking about, in that there's other things that you do besides writing code, you also spend a lot of time reading code, right? Because you're trying to, you're supposed to make a change. Okay, but you got to go in and figure out exactly what the code does first so you can figure out exactly where to make your change. And often, like, the written documentation that's there lies, right? So, for example, this particular VI says, it's called array 1 to n. So you would think if I put in n, say n is 3, I would get out an array that is 1, 2, 3. But if you're looking at this carefully, and hopefully everybody in this room can pick up on this, this VI does not do what you would think it would do based on the icon in the name and the context help, right? If you run this, right, the iteration counter starts at 0, so you get 0, 1, 2. But you don't pick up on that unless you actually run the code, right? Because if you're like really just quickly glance at it, you glance at the documentation and you assume it's correct, right? But code doesn't lie. And so here's the very simplest unit test. And this might go to a part of your question about complicated tests. This test is really simple, right? We've got the code that we're testing, and we drop it as a sub VI. And we got an input, and the input, we're not calculating anything for the input. It is just a simple constant. And the expected output is also just a constant. And we're wiring them into an equal, and we've got a pass or fail. This test, like, if there's a problem and this test fails, there's no debugging here, right? Because it's pretty much like you look at the input and you look at the expected output and you say, is that what I would expect if I put that input in? And if it is, then as long as you got the equals and not like some greater than or less than or not equal or something, like that's the test. And so here there is no debugging the test really. And this is absolutely like the simplest form of unit test, right? The easy code to unit test, and we'll talk about what makes test code hard to test. The easiest things to test are things that are just straight functions. It just has an input and an output. It's all in the connector pane. It's really easy to do something like this. And it's not all like this, and we'll talk about those situations later. So this is grossly oversimplifying the problem. All right, so reasons to do unit testing. It allows us to change code and add features without fear of breaking existing functionality, because the worst thing is you add something, the thing you added works and you know it works, but you don't have a way to test everything else. And so you ship the code out and then your customer says, hey, you broke this other feature way over here on some other part of the code. Okay, we really don't want that. The other thing is unit tests help us pinpoint problems when we do break something. So we didn't talk a lot about that, but unit tests are very granular. And so when we have a problem, the failing unit test will point us to exactly which VI that we need to go look at to figure out what's going on. And they act as truthful documentation to help us understand our code. So going back to this previous example, or if you wanted to know what that VI did, you could open up the test for it and look at the test. And the test clearly states, if I input 3, I expect to get 1, 2, 3 out. And to tell if that's true, all you have to do is click the run arrow. And if the pass says true, then that's what actually happens. All right. And the end goal of all this, right, is to help us deliver, change, and maintain our code. So to the point of I couldn't see who was talking earlier, but the guy I was talking to earlier, right, of already testing your code, right? If somebody told you to write code to convert Fahrenheit to Celsius, you'd write the code, and the first thing you do is go to the front panel and type in some value that you know, like 212 degrees Fahrenheit is 100 degrees Celsius, and you would click run. And if you got 100 degrees out as the output, you'd say, great, that's awesome. And then you'd probably pick 3 or 4 numbers that you know off the top of your head, and you would do that. And if everything worked, you'd say, all right, great, I got it, it's working. Now, when it comes to automating things, right, we all tell our clients about the benefits of automation. We tell them, hey, if you automate this, it's repeatable, there's less chance for human error, it's faster, it's more reliable. Well, going to the front panel and manually entering values is not very repeatable, because I might enter a handful of values and somebody else might come to test my code and they might enter a different handful of values. And there's always a chance for human error, because I have to know what the 2 corresponding values are. I have to enter the one correctly without any typos. I have to press run, and then I have to look at the output and make sure that it actually matches what I'm expecting. And it's not very fast, because there's this manual action of having to enter the values and run it and then enter another value and run it again. It's just not very reliable. But, right, we tell our clients, hey, if you automate stuff, you can get all these benefits. So why not automate the testing of our code and turn it into a very simple unit test? And again, this should look similar to the other previous unit test. All we do is we create a test VI, we drop the code we want to test as a sub VI, and we create some constants, and we use an equals. Very simple. And this is like the bare minimum of unit tests, and we're going to build on this in a minute. So on the left, it's just like, one input, one output. If you want to test multiple values at once, you could drop a for loop around your code and do something like the thing on the right. One thing I will point out is definitely be careful when comparing doubles. Hopefully everybody knows that when you're comparing doubles, right, you should always have some sort of tolerance because it could be off at like the 100th decimal place or something, and they're not equal. So,
Sam, do you have an example of that just for the folks that aren't used to doing that, like in range and coerce, or just checking if it's right? Like what's
so what I would do is I would say I would take the two values and subtract them, and say the absolute value of the difference should be less than some tiny bit. As we'll see, most of the frameworks take care of that for you and have a thing that will let you add a tolerance, and so it's very easy. But if you're doing it yourself, you just subtract the two values, right? That'll give you the difference between them. And then the absolute value of that should be less than 0.01 or whatever you decide is good enough for your test.
There's a numerical constant on the numerical palette, which is called epsilon, and that is our machine epsilon. That is the minimum. That's the maximum error you get in a double.
So you can also do that. Yeah, so that is also true. But however, I'm not sure that entirely holds up, because if you're doing some calculation where you're doing a bunch of multiplies and divides and subtracts and all those things, I don't know if you chain a whole bunch of mathematical operations together, could you get higher than epsilon? I don't really know.
Yeah, Steve, do you know the answer to that question?
Well, what epsilon addresses is the round off, if you will. There's round off in doubles, just like there's round offs in integers of the machine. And you're right. If you do a chain of calculations, do them in the right order, you can end up with quite a bit more than epsilon error.
Yep.
So
I was.
You're in trouble.
Yeah, I was very much aware of the epsilon thing, but yeah. So thank you for pointing that out for anybody else, because I didn't mention it. So the test that I showed you is a great start, but the problem is I've got to manually know where that test is in my project. I've got to know that, okay, I changed something, or I want to go rerun all my tests. So I have to go find all the tests, and I have to open each one and press run and verify that, okay, I got the green pass, and then I open the next one, run it, verify I got the green pass, right? So it'd be really nice if in my project, like the video I showed you earlier, I had one place that I could make one click or one command or whatever that would find all the tests in my project, run all of them, and then report the results back. And for reporting the results, we want to be able to have some sort of GUI so that as I'm running it interactively, I can see all the tests running and I can see what's going on. And also for the reporting, it's nice if it can create some sort of text file or something so that later we can automate these tests as part of like a CI system or something. So that, every time we make a change and we check it into Git or Subversion, the server can see that and run all the tests and make sure they pass. So, and our frameworks in LabVIEW are going to take care of all this for you. So if you didn't know, there's at least 5 unit testing frameworks in LabVIEW, and I think there's even a few more that I'm not mentioning here. The 2 on the left are the most popular. There is Karaya, which is kind of the new standard, and VI Tester, which is the old standard. There's NI Unit Test Framework if you're a masochist. There's the AST Tester, which is not as polished as some of the other ones, but I really like it because it's like the bare minimum. Like your tests look a lot like what I was showing you. You have, basically all it takes to be a test for AST Tester is you have to have a pass Boolean coming out of it. And there's like one little hoop you have to jump through so the test thing will recognize it, but that's it. The other ones are a little bit more complicated. And then there's Insta Coverage. One of their claims to fame was that they worked in NXG, which doesn't really matter anymore. Their new claim to fame is that they are ISO certified and that they calculate code coverage, which is basically a way of saying, how much of your code is actually being tested by your tests. So if you need either of those things, then instant coverage is the one to use. NI unit test framework, I highly recommend you stay away from it. It's a bear to use, and nobody really seems to like it, and NI supports it barely. So, actually, has anybody used any of these before we move on? Are people doing any kind of unit testing?
I've used Karaya. I like it because it's very simple to use, and you can chain multiple tests and just hit one run button and it'll test everything.
Cool.
Yeah,
Thank
we
you,
use
Roland.
Karaya as well.
Yeah. Karaya seems to be the new standard. So anybody who started doing unit testing probably in the past 5 years probably uses Karaya, and anybody who's been doing it longer probably uses VI Tester. It just tends to be the way it works. There are some differences. VI Tester is a little bit harder to use. It's object-oriented. It's a little more strict. The thing I like about VI Tester versus Karaya is VI Tester forces you to put all your tests inside a class, and it has this like hierarchical organization. And I find that Karaya kind of lacks that. So I find that with Karaya, you kind of end up with tests everywhere, and they're not very well organized. You usually end up having to like do all that yourself and come up with some way to organize them. But I'm going to show you guys how to use Karaya here, just because it's the most popular. It's the new one. It's the shiny one. You can install almost any of those testers via VI Package Manager. Again, if you're going to use the NI one, which I don't recommend, that you have to go through NI Package Manager, where you can select it when you install LabVIEW. Karaya, you just look for Karaya and VI Package Manager. The only one you really need is this Karaya Unit Test Framework. The CLI extension is if you're going to use it, call it from the command line for like some sort of automated testing. So like taking it a step further and having something that like a CI system that runs the test automatically when you check in changes to get or subversion. All right, so creating a test in Karaya is ridiculously easy. So all you do is you open a blank VI, you open up QuickDrop, and you type in new test. And there's also on the palettes. You can find this through the palettes if you don't like QuickDrop, but QuickDrop's really quick and easy. So you type in new test, you hit enter, and it drops this on your block diagram. And there's two VIs there. The one on the left is called define test. And this is basically what tells Karaya that this particular VI is a test. It's what lets Karaya find it so they can run all the tests in the project. And you can give it a name. I almost always leave the label empty because I like it being the name of the VI because then it's easier to find. Because it'll give you a report and say this test failed, but if the name of the test is different from the name of the VI, then you have to go search and find it, and it's a pain in the butt. If it's the name of the VI, you just go find the VI and open the VI, and it's much easier. But that's the first thing you should call in your test. And then this thing on the right that is called an assertion, and it's going to replace our equals. And it's got a bunch of different settings here. So basically, assertion just means I'm saying this thing is true. So I'm saying that this value that I'm passing in is true or false, or that the two values that I'm passing in are equal. And you can see they have an almost equal that has a little tolerance built in there. Or you can also assert that, hey, this error wire that I'm passing in should have an error or should not have an error. That's what's under the error thing. The reason to use this instead of the little equals is because here, it gives you more options like the greater than or less than and all that, but also it can record information. So what the values that you pass in are recorded by the framework. So it can say, instead of just saying, oh, the test failed, it could say, hey, I expected a 5 and I got a 4. And that just makes the test reports a little bit more useful. And then, and the other thing is you can have an assertion label. So you can have multiple of these asserts for like a single test. So for example, if you're testing a sub-VI that has like 3 outputs, you might have one of these assertions for each output. And so the assertion label, you can label it for which output you're looking at or something like that to make it a little bit easier. That assertion label will show up in the test report too. Questions so far? And if we take our previous test and we want to convert it to a Karaya test, all we have to do is drop the thing that defines our test and drop our assertion in there. In this case, I put the assertion inside the for loop because for whatever reason, the almost equals doesn't work with arrays of doubles. So, but with individual values, it works just fine. So this test will actually have 3 different assertions. So it's each set of numbers, it's doing an assertion to say that, you know, when I input 212, I should get out 100. When I input 32, I should get out 0. So that's how you write a test in Karaya. It's really easy. And running the test is really easy in Karaya. There's a quick drop shortcut, Control Space, Control U. It's really quick and easy. It will go through your project and find every test in your project and run them. There's also, I think there's a way to invoke it from like the tools menu or something. And here you can see that I ran my test and it has 3 assertions. So each time the for loop ran, it asserted, and only one of them passed, the other 2 failed. So there's a problem in my code. And the problem is I didn't actually implement anything in this VI. It's just blank. So it always outputs 0. So in the middle case, it's expecting 0, so that test passes, but the other ones fail. Which brings up another point that I've forgotten to mention the last time I gave this presentation. You want to actually watch the test fail to make sure that, like, you know, you're not getting a false positive. Make sure you're actually testing what you think you're testing. Questions so far?
I was going to ask about the, I know you mentioned the almost equals for the arrays wasn't quite working. Is that because that maybe that almost equals is like, do they roughly have the same amount of elements in them instead of, are they roughly the same value? Or is that asserting the value?
No, it just, yeah. So if you wired both of the arrays into there and you set it to equal, it would check that the 2 arrays are exactly equal. They're almost equal. It just, for whatever reason, and for that to work and not generate an error, the 2 inputs have to be doubles and they can't be arrays. It just has something to do with the way that's coded inside that VI. And Karaya is all open source, by the way, so you could double click on that VI and open it up and see what's going on inside of it, and then you would probably see what I'm looking at, or what I mean when I say that. But
yeah.
So if you want a tolerance on doubles, you have to evaluate them individually instead of looking at an array. Or you have to calculate the tolerance yourself and do something outside of the assertion. So, all right. So first people say is, well, what type of test should I write? And the very first type of test that everybody tends to think of is what I call the happy path, and that is, hey, everything's working wonderfully. The inputs are within the correct range and everything, and it calculates the output, and there's no errors or anything. And you should definitely write tests for that, and that's probably going to be the first thing you think of. But you should also check for edge cases. So there's a phrase out there called zombies, and I forget exactly what it stands for. But if you look that up, there's a whole bunch of information on that, and it's supposed to be a reminder. But basically, let's check for 0, negative numbers, not a number, plus or minus infinity, some boundary conditions, right? Where if the number is less than something, it's supposed to do one thing, and if it's greater, it does something else. Don't forget about invalid inputs. So empty arrays, an empty path or not a path, empty strings, not a reference, things like that. And then error scenarios. So, you know, expected error scenarios. Like if you try to divide by 0, it should generate an error. Okay, well, like let's make sure that the error output actually generates an error and generates the error that you're thinking. And then another time to write a test is anytime you find a bug in your code. First of all, the first thing you want to be able to do when somebody reports a bug is you want to be able to recreate the bug, right? So you want to verify that the bug actually happens. And then you write a test to catch that bug. You write a test that fails, that when you fix the bug will pass. And that's your proof that you actually fixed the bug, right? Because you've got to, if somebody tells you there's a bug and you fix it, you're going to do some kind of test to verify that the bug's actually fixed. You might as well create a unit test to do that if you can. So the next thing becomes, you know, if you've got a large project, you've probably got a fair amount of tests. So, you know, if you're testing every VI, which, hey, I don't recommend testing every VI, right? You want to test behaviors, and that could be like a couple VIs chained together, or it could be like a method on a class or something. But you want to be very careful that when you're testing things, you want to test like higher level behavior rather than like the individual, like, oh, how is it doing this exact calculation? Because if you make your test too specific, then any change you make to your UI is automatically going to break all the tests. So you want to be able to like have the same behavior, but if you change the way that you do that behavior, like the implementation, you should be able to change the way you do that and still pass the test. So that's like a little nuance there. But so I'd like to use some kind of naming convention for my tests. And I generally start with test underscore whatever I'm testing, and then the behavior that I'm testing. Part of that is that for VI tester, the name of the test actually has to start with test. So for Karaya, that's not the case. So you don't necessarily have to adopt that convention. Something else to do is in your project, have like a virtual test folder that you can throw all your tests in to keep them organized, to make them easy to find. When it comes to libraries and classes, if you've got tests that test a library or class, you probably don't want to put them in the library or class, because then when you build that, or if you hand that off to somebody else, all the tests are automatically included. So generally I put them beside the library or class. I've either have some kind of parallel folder structure, or maybe I just have all the library files are in a folder, and there are also a bunch of test files in there, but the test files aren't part of the class itself or the library. So this, going back to the behavior thing, this is a very common pattern to use to help you write better tests, and it's called the 3-part test. And basically, it's given, when, then. And it's the one time that I actually recommend that you use a stacked sequence structure in LabVIEW, because it makes it really clear. So given is kind of the setup for your test. And to the point earlier, you want the setup to be really light. You don't want a whole lot going on in there if you can help it. Right, so given, in this case, I created an object that is acts like a stack. So if you don't know, a stack's kind of like a Pez dispenser. You put things on it, and then you pull them off in the reverse order. So it's basically just like kind of like a queue, except instead of pulling them off in the same order they went in, you pull them off in the opposite order. And so, I've created a stack, and then when I push 2 items onto the stack and then pop them back off, then they come off in the right order. So they come out in the reverse order. And so hopefully, even if you didn't know anything about what a stack is, you can look at this code and you can quickly say, oh, I think I know what that stack is doing. Right? Because it looks like he's putting things on in this order, and he takes them off, and oh, they're in the opposite order. So hopefully that's clear. And this is kind of what I mean by like code acting as documentation. So this is the test code, but if you want to know what the stack did and you saw this test there, you could quickly and easily look at this test and get an idea of how it works. So I think of, sometimes test code, you can think of it as example code. So I'm writing an example of how would I use this and what would I expect to happen. And if you think of it that way, I think you're less likely to do that over specification thing where you're like too caught up in the details of how things work that then you can never change them. Because this doesn't say anything about how the stack is implemented underneath, right? I could change, like right now, the way that stack works, it's a lossy queue, but I could change that and make it an array. I could change it and make it anything else, and it would be just fine. The test would still pass as long as the logic was correct, as long as like the external actions were correct.
Can I
All right,
ask
so
a
I'm
quick
sure
question
some of
on
you,
that?
yeah. Yes.
So in there you have a constant wired to the for loop, the 2. Is there any reason why, and maybe this makes it more complicated of a test, why you wouldn't just use the array size from the constant that you have over to the left?
Well, in this case, that would work, but I try to avoid putting any logic in my test at all. Like,
Okay.
As little logic as
that
possible.
way you're
in this
just
case,
everything's
I
constant.
did put the for loops in, but everything's constant, so it's really easy to debug.
That makes sense. Okay.
Now, obviously, like debugging, like, I trust the array size thing's going to work just fine. And yeah, that might make it easier that, like, if I would decide instead of testing 2 things, I want to put in 3 or 4 things and see if they all come out backwards. Yeah. But if I do that, I have to change the constant. Notice also, like, the expected items are also, well, in this case, they're different because it's a different order. But I could have just reversed the array and wired that in as well, right?
Yeah.
But then I'm getting into the situation that the guy mentioned earlier that you spend time debugging your code. Here, there's nothing to debug. There's no, The only logic in the test code is the order in which I'm calling things, right?
Sam, I've got one kind of follow up. So, does the Karaya function, does it detect if you've got different size arrays going in? Because one thing I would be worried about is, say you add a third element to the first array, but you forget to change the other two, then you're going to get a false positive simply because you didn't actually test your new case.
So they have to be same number of size, same order. So arrays, it should generate a failure if they're different sizes.
Okay, cool. That's great.
Yep. You can test that very easily by just wiring up a simple test and wiring two different sizes and see what happens. But I'm 99.999% sure that should generate a failure. And also the order matters. So one of the things tricks that I've learned, if you don't care about the order, if you can get your code to output a set instead of a array, right? Because sets don't care about the order. So if you know that everything's unique and you're not going to repeat anything and you don't care about the order, output a set, and then it's very easy. You should wire two sets into the thing, and it's very easy. Because if you're using arrays, like say I was doing something and I had the output and I knew what was in the array, but I didn't care. I didn't care about the order. Then my test is very brittle, because if I change the way in which say I'm like filtering a list, right? And I'm pulling out all the list elements that are greater than a certain value, right? I know what should be in the list, but I don't necessarily know what order they should be in, right? And I don't care what order they're in. I just care that the array contains all those elements. Then that's a problem, because arrays inherently have like an order to them.
Could you?
Am I making sense?
Yeah, that makes sense.
Okay. I mean,
I was
if
gonna
I'm not, please stop me.
I was gonna say, if you wanted to use, like, for example, the two inputs going into that equal, you could do like a sort 1D array type thing, for instance, and since it's being done on both, right, it should be the same.
Yep.
If you didn't want to use a map or set.
Yeah.
Okay.
Yeah, no, that would work. And if you had duplicates, you might have to do that, right? So if there were duplicates in the array that was coming out, but you didn't really care about the order, because that's one of those things where you're over specifying. If your code makes no guarantee on the order of how things come out in the array, it just says, hey, here's an array of all the, like, for example, say you're like parsing some JSON or something, right? And you say, here are all the elements in the JSON. You don't really care about the order of those, right? You just care that like they're all there. In that case, then you would do something like you were saying, where you could sort them. So that answered your question. So I'm sure some of you guys are out there and you're like, hey, Sam, this sounds great. This is awesome. I really like this, but how the heck do I integrate into some code like this? Because I've got this big, huge spaghetti mess. And that's a very valid question. So here's some tips for dealing with legacy code. You guys are all coming to user groups, so I assume and I hope that means that you're all using source code control. So first of all, use source code control and make really small changes and make really targeted commits. So if every time you make a change, you make a commit, and you find that there's a problem, it's very easy to undo that one commit because it's only that one little change. And that should work really well. If you make 10 changes at once and commit them all, and then, oh wait, that introduced a problem, then you're undoing all 10 of those changes at once. There are some ways around that with Git. You can do some fancy stuff where you just pull the changes from one file, but that gets more complicated. Next thing is to try to get some end-to-end sanity tests in place. So some way of testing it. I mentioned I have a project where I can't test it without the hardware, and I'm doing it remotely. But I at least am able to send them the code like every couple of days and say, here's the latest one to test. Can you please plug it in and just run a quick test and make sure that it all works? There is a thing called approval testing, and it's totally worth looking that up. And it's kind of like this idea, I think it's been called like the golden master thing, or golden template, where basically you run the code, you gather some output, and then you save that output, and then you run the code again. And if the output has changed, then you have to approve the change or not. And there's a way to do that, and it's really interesting. I've been meaning to try to put something in place like that for LabVIEW, like a built-in type of framework for that, but I haven't got around to it yet. But one thing I definitely don't recommend is don't just take that spaghetti code and immediately say, I'm going to go start writing unit tests for this because it doesn't have any tests, because you're going to drive yourself nuts. And particularly if you are not already writing unit tests, because you're kind of learning two things. You're learning how to deal with this legacy code, and you're also learning how to write tests. The easy thing is to, if you're going to add a new feature, write that feature in parallel and write tests for it, and then at the last minute, integrate that with everything else, right? So if you've got to add file logging to something like that, write a file logger without touching that code at all and just write it off to the side and test it and make sure that, hey, when I pass it the right stuff, it logs it. That's great. Then go integrate it into your legacy code. And now, once you've done that, now part of your legacy code is actually being tested now. And so you're at least taking a step in the right direction. And I'll also do that for bugs before you fix them.
Sam?
The next thing,
that's
yeah?
The, hardware simulation. So
Absolutely.
So what I'm saying is that substitute data output of your what you're expecting with a simulator, and then use that data to do your testing.
Yes, absolutely. So I think what you're saying is, so there's a couple different things you can do. One, you can actually record data and then have some sort of playback thing. So that's one way to do it. The other thing, and if I'm misunderstanding what you're saying, let me know, but if you're doing any kind of hardware stuff, it really makes a lot of sense to wrap it in a class and have an interface or a parent class that you can inherit from, so that your test code, then you can use that to simulate signals so that you can write unit tests for code that uses hardware without actually having the hardware there. And we're going to talk about that in a few minutes. I have a slide on that.
What I'm talking about is actually, okay, so let's say you have some hardware over time that's going to create an array of data.
Mm-hmm.
Then instead, you create a simulation of that data that you want to test for.
Mm-hmm.
And this also helps you go for the fringe cases that you might never be able to do with a real system.
Yes, actually. So that is also a good point. So fringe cases, for example, like you're reading stuff from an instrument, how do you test that when that instrument generates an error, your code handles it correctly, right? Because you got to figure out a way to force that instrument to generate an error, right? But if you have some sort of hardware abstraction layer, you can inject an error. And as far as your code's concerned, it just knows that, hey, this hardware thing that I'm talking to generated an error, and it doesn't know if it's a simulated error or a real error. Then that's a good way to test that. So am I kind of on the right track with what you're talking about?
That's part of it, but what I've done is there's been some hard data sets to reproduce. And then if I can, it's a direct substitution for the hardware. I go into, let's say, a simulation case, and it substitutes the data that you would expect on every loop. You would load with a preloaded simulation data. And then you can test any set of data that you want to see if the system is going to react to. You also could know what your calculations might end up to be at the end, and make sure that if you get that data set, you get the final output you're expecting.
Yes. So I think you and I are talking about the same thing, but slightly nuanced. So you mentioned a case structure. So what I'm suggesting, and a case structure totally works for that. What I'm suggesting is if you wrap your hardware stuff in a class, instead of a case structure, you can use dynamic dispatch to execute a different, instead of calling to the actual hardware. Right? Normally you would take the hardware call and you would wrap in a case structure, so you could press a simulate button, right? And the Boolean would say, hey, skip calling the hardware and just return this data. Basically, if you create a hardware abstraction layer and you inject a simulated class, it does the same thing.
Yep, sure, that would work.
So, yep, either one works. What you're talking about is more like the down and dirty, just like it works. And what I was talking about was more of the computer sciencey, more fancy way of doing it. But yes, they both do work. So hopefully that answered that conversation. We can move on now. So the next two tips I have is to do some safe refactoring. So there are certain refactorings that you can do. And refactoring, by the way, is just changing the code to make it easier to read and understand and maintain without actually changing the functionality. So somebody using your code would have no idea that anything changed, but under the seat, you're changing the bottom of the iceberg. You're rearranging all the stuff that the end user can't see and doesn't care about. But you really care about it. So you do things like block diagram cleanup, and I have a question mark beside that because obviously we all know that doesn't always work the greatest. But that's not going to break your code. Creating a sub-VI is probably not going to break your code. Renaming controls, indicators, sub-VIs, classes, those things hopefully shouldn't break your code. There's some small chance they can if people are doing stuff dynamically. That's why I have safe in parentheses. But like adding comments. Comments are easy. That's not going to break any code. Icons, not going to break anything. VI descriptions, not going to break anything. Our clustering related values to reduce wires, that has the potential to break stuff. But you know that can help. So you can do all these things to try to clean up the code so you get a better understanding of the logic and you can see the patterns of what's going on. And then that's going to help you to try to organize it better. And then the last thing we're going to talk about, and we are coming close to wrapping it up, so I don't know what time we're at, but if anybody's worried about time, we're getting close. So the last one is separate logic from hard to test code. So we'll talk about that in a second, but if you're dealing with legacy code, these are two books that I really like. The one on the left is an ebook. It's pretty cheap. If you go Google it, you can find it. 14 techniques to quickly and safely rescue your code base. It mentions a handful of little techniques that you can use. Most of them are very simple. You can learn them in 5 or 10 minutes. It tells you what the technique is, when you might apply it, how best to use it. It's really good. It's something you pick up and start working on right away. Working effectively with legacy code is the standard book. It's very computer sciencey. So if you're not a computer science person, I recommend the other one first. But if you are into the computer science side of things a little bit, working effectively with legacy code is really good. And it's got lots of good information in it. But it is a little harder to digest. The first aid kit is very practical. But what makes code hard to test? Well, so the examples that I gave earlier were kind of simplifying things because if you noticed, all those VIs had an input on the connector pane and an output on the connector pane. In that case, they only had one, right? But you could have one with multiple inputs and outputs. And you can figure out how to do that because it doesn't, all the inputs and outputs are available in the connector pane. There's no like side effects or other things going on. There's nothing else that you have to interact with. What makes code hard to test is having to interact with other things like the GUI, right? So if it's got a dialog box that pops up in the middle of it, well, you can't automate that because you have to have a user there to click buttons. Same thing with databases and files, right? If you're interacting with the database or file, well, you've got to potentially pre-populate that database and file with something, and then you have to go and access it and pull data back. And network and communication stuff is similar. Like, you know, if you're talking to something over the network, well, that thing has to be there in order for you to run the test, and it has to be in a certain state. Right? If you're like, pulling files down over the network or something, well, those files have to exist. So the key to testing this type of stuff is to separate the logic from the hard to test code. So here's part of a serial driver for something. I made this up, but I'm sure you guys have seen similar code. We're taking a command, some parameters, a channel number, and we're formulating some kind of string that we're sending over the serial port. Now, as this VI is written, testing this VI is really hard, right? Because in order to test this, we have to have an instrument on the other end of the serial port. And in this case, we're not reading anything back. We're just sending a command. So how the heck does our LabVIEW code verify that this instrument actually did whatever it's supposed to do? Right? Maybe we're setting some parameter, right? In this case, the guy who mentioned that, hey, you spend a lot of time debugging your test code. Well, you could spend a lot of time debugging your test code because you might have this writing that some value and setting some value, and then you would have another VI that's reading that and parsing whatever comes back and doing that and then doing the comparison. And so our tests get really complicated. But if we can separate the logic, and if you think about this, the logic that's going on here is how are we formatting the string that we're sending across the serial port? Because that we can verify in LabVIEW really easily, right? So we can take all that formatting code, wrap it up in a sub-VI, and if that sub-VI is a public sub-VI that we can drop anywhere, we can drop that in a test VI, and you can say, hey, if I select channel 5 and command is set voltage and the parameter is like 5 or whatever it happens to be, I can verify that that string is correct. And then the actual writing to the serial port, we don't really have to test that from a unit test point of view, because I pretty much trust that LabVIEW's tested when it's shipped out. And if I have the serial port set up correctly and I give it the correct string, LabVIEW is going to send out the correct data on that serial port. Right? So we don't need to test this VI right here. We don't need to unit test it. Right? We should still test this in our integration test. Right? So at some point we need to verify that, okay, the string that the manual says to send out, that we're sending out to this instrument, actually has a desired effect on the instrument. Right? But we only really need to do that once because the instrument's probably not changing. And we can do that at an integration test time. So when we're testing our whole system or larger parts of our system, we can manually hook up an instrument and we can run through a bunch of commands and say, yep, okay, it does what it's supposed to do. So that kind of brings us to a really brief look at what I call the testing pyramid. And at the top, you have your site acceptance test or factory acceptance test that kind of tests everything end to end. And then at a lower level, you have what I call GUI testing, which is basically just somebody standing there pounding on the keyboard trying to find errors. And then at the next level, you have integration testing, which is testing that all the various pieces function together. So this is where you would take your hardware drivers and actually hook them up to the actual hardware. And unit testing is where you try to isolate just the logic that calculates the strings that you're sending to your instruments. Right? And as you go down, it gets bigger because there's more and more tests. So like you might have hundreds of unit tests on your project, but you probably only have one factory acceptance test. And there is a video, and I will send you guys a link to this, but you should totally watch it. It's the lump of coding fallacy, and it talks about how you spend your time throughout the day. It's only a 10-minute video, so it's probably the best 10 minutes you will invest into your software development career. But it's an amazing video. The guy's just a genius, and he explains it really, really well. And if you want more information on any of this, I have my blog. I write a variety of articles. And I have some specifically on unit testing. And then I run some workshops. I have a unit testing intro, which is basically takes what we've talked about here and has you practicing it and writing some very simple tests. And it goes about as far as we did into separating the logic out and stuff. And then the full workshop goes into all sorts of stuff with the objects and how you can create simulated instruments and stuff and get data back and do a lot of things there. And then there is a unit testing forum on the NI forums. And there's 3 books there. Most applicable is probably LabVIEW Graphical Programming. That's by Fabiola. It has an entire chapter. It's only like 80 pages, but it goes through all the different unit test frameworks and how to use them and how to write tests. It's more of like the how-to. The other 2 books are more of the why. X-Unit Test Patterns is a great book. I really like it, but it's 900 pages and it's not too computer sciencey. The Art of Unit Testing is probably only like 150, 200 pages, and it's a much nicer book. I found it a little bit harder to follow because it's a little computer sciencey and some of the terminology it uses and stuff, but they're all good and worth looking at. And that's the end of my presentation. So hopefully you guys all found that useful.
I'd say it was useful. Absolutely.
Yeah.
Thank you for presenting.
Yeah. So, no, I liked all the questions. It was good. Lots of good questions. So, if anybody has any more questions, I can hang out and answer them. Or I don't know what you guys usually do for the rest of your meeting, but
Yeah. Well, yeah. Does anybody have any immediate questions right now?
I'd like to ask a simple question. I had a class and I had a private VI, and it was important that it behaved properly. And I was using Karaya, and you can't call it a private method, so I had to make it public. Is that the recommended way to do it?
So 2 thoughts on that. One, if that method is that important, maybe you put it in its own class that's like public, and the class the class that's using it like has like it as a private member, right? Like using like composition. That's one thought. The other thing you can do, Roland, is you can create a class. So you can, instead of making it private, you can make it protected. and then you can make a subclass, like a child class, just for testing. And you can have a method in the child class that basically just wraps that protected method, right, and has the same inputs and outputs, and then you can test it that way. That does run the risk that, like, in your program, if somebody else can create a child class, they could then access that. So that's, but yes, in general, testing private methods. So testing private methods is like a slippery slope, because what happens is the reason you make that method private is because you want to be able to change the way the class operates internally, right, without affecting the callers. It's the whole idea of encapsulation, right? The caller of the class only really cares about the API of the class, the public VIs that it can use, right? So it cares like, hey, I call this method and something happens, and I call this method and something happens, and you return this value. And so that internal private VI should be able to change, and the caller shouldn't care. And also, if it's in your class and it belongs in there, should be a way to exercise it from the outside as well, right? So from your public API, you should be able to exercise that class somehow and somehow verify that you're getting the correct output. Am I kind of making sense?
Yeah, thanks for pointing out 2 different ways I could do it.
Yeah, so there's 2 ways to do it, and there's a reason not to do it. So, you can take your pick out of which one of those philosophies you most agree with.
Yeah, it's food for thought. Thanks.
Yep.
Cool. Any more questions? All right, great. Well, thanks a lot, Sam. This is where we would normally give you applause and stuff, but virtual applause. So yeah, thanks a lot for joining us and sharing that. That was really really informative, and I like how you actually went into detail on how to do it and like some tips on using it and so on. So that was really useful, I think. I heard in the beginning and leading up to this that a number of people were interested in learning more about how to do unit testing. So I think this worked out really well. So thanks a lot.
Thank you.
Cool. So let's
I have one thing. Is there a way to get this presentation posted on the user group website?
guess that's up to Sam.
Yep.
I'm perfectly fine if you want to do that. I know somebody said they were recording it, right? To get recorded.
Yeah, we are recording. Josh is recording the meeting, so we'll at least have a video on YouTube.
Well, I will say one of the links was obscured when you were sharing with the little bar that Google puts up that says, "Oh, your screen is being shared," and so it did obscure that one with the video.
Oh, I will post that right now, and I'm happy to add that later too. But yeah, I can go copy that. It is. If you take nothing else away from this presentation, you should go watch that video, because I think it will change the way you think about what you do, which is very interesting.
Awesome.
How do I get to the chat?
There should be a little box in your bottom right corner.
Oh, on the right. Yeah, there we
Feel
go.
free to email me the presentation too, and then I can post it if that's easier.
Okay. Yep,
Okay,
we can do that. I will just email it to you. But
Awesome.
yeah, there's the video. Yeah, you won't regret watching the video. Totally.
Cool. All
It's
right.
far better than my presentation. So.
Awesome. Well, let's go ahead and take a quick 5-minute break, and then we'll come back around and do some more utility VIs. I think Eric, if you are ready to go, why don't we have you set up to kick things off, and then we'll move on from there.
Sounds good. I'm ready to go.
Okay, great. So
Me too.
Awesome. Great. At 6:07, Eric will start. And so since we got a little bit of took a little time to get rolling, we're probably gonna go a little bit past 6:30 is my guess. But I guess we'll just keep that in mind as we're presenting to see if we can get through everybody as soon as possible. Oh yeah, and Jomar's got to talk about the coding challenge. Maybe let's do this. Let's have Jomar announce the coding challenge first at 6:07, just to make sure everybody hears it, and then Eric will take over from there. Deal? Great. Cool. All right. Break. See you in a few minutes. And Sam, feel free to stick around. Otherwise, if you've got places to be, no hard feelings. We really appreciate you coming and helping us out. Two minutes and counting. So on my list of people to present, we've got Eric, we've got Josh, we've got Tom, we've got Steve. Is there anybody else that we're expecting?
Why am I always last?
Yours is last?
No, I said, why am I always last? We're always over time, and then I'm last, and then I'm rushed, or people have left, but that's fine.
I did not actually have people in that order. That was just the list of people.
I'll go last. Yeah.
So that's cool. We'll do Eric and then Tom and then Steve and then Josh. Maybe we should announce the topics so that people know, or should we keep them secret? I don't know. I could see both.
They gotta stay for the presentation to find out what it is.
We could just show them the code and make them guess what it does. What do they say? If it's hard to write, it should be hard to understand. Isn't that the rule?
I don't suppose anybody's got unit tests written for their the code they're going to share already, do they?
No.
Well, Sam was supposed to do that, wasn't he? Wasn't that part of his arrangement?
Oh yeah, he's going to walk us through how to make unit tests for our VIs, right?
No, he's going to make them for us.
You can certainly see what he says about that. But it is 6:07, so let's let Jomar kick things off here. All you, Jomar.
I know I'm muted. I'm trying to present right now. Okay, I assume y'all can see the screen.
Yes.
Okay, so our challenge for this quarter is Wordle. So I'm going to do just a couple slides on Wordle, and then we'll actually look at it. But yeah. So yeah, it was developed by someone named Josh Wardle, and it was a gift for his partner, which I always thought was kind of cool. So since all of us are programmers, we need to think of good gifts for our spouses. So just a thought there. But yeah, like his relatives loved it, and it became like an obsession with his relatives. So they all wanted to do it every day, and it's become super popular. And yeah, the guy that made it got an undisclosed 7-figure sum. Nobody knows how much that is, but sounds pretty good. And what's kind of cool is that the code is public. You can see it in any browser. It's all right there to show. Well, I'll show it. Wait, in just a minute. But yeah, you have a 5-letter word to guess. You get 6 chances to guess the word, and then there's some 10,000 or there's some 2,300 available words that could be answers. There are 10,000 other words you can guess, and you can play hard mode, and you have to reuse the information. So let's take a look. So if you go to this website up at the top, then you see you have your 6 guesses. I have a feeling most of y'all have seen Wordle, but one person on the committee had never heard of it, so we'll just go through that. So let's just say that my first guess will be solar. Yeah, thank you for putting up the link. So now I know the S is yellow. So now we have to think what's another word that has an S but the S isn't in the first position. So how about someone throw out a word that they want to try. Don't say the answer.
Funky.
What?
Funky.
Funky. So no letters. We know that the answer doesn't have any of those 5 letters. Y'all want to do another one, or should we just skip to the end? Let's see. Spoiler, this is the answer, by the way.
You're just that good, Joe Meyer.
I know.
Third time every time.
You today, it's only happened 4 times for me. So yeah, it will show you your statistics, assuming you're always on the same browser on your phone. So yeah, it's kind of cool to see my my streak up. So
undefeated.
I am. I have been very lucky. So if we go into in your browser, you can go to developer tools, and you can see in this main, you can see all of the source code, and it's all right there for you to try out. And I copied it and I put it in into Notepad, and then eventually I made my own. I've already done the challenge, obviously. So I've made my own text files of possible guesses and possible answers, and it's all in the code. We scroll down a lot, you can see there's eventually tons and tons of words. And just as a note, in case you want to do this, possible answers are not included in possible guesses. So if in the original source code. So I implemented it that way too.
So what you're saying is, if the word is not in the dictionary of allowable words, it just says you can't guess that.
Yeah. Oh yeah. I guess I didn't show that, but yeah, you can only guess words that are real words. But in possible answers, if cigar is not in this list. Yeah. So the lists are exclusive.
Cool.
So yeah, let's all try to do Wordle. If you want some other ideas, I did hard mode in my own implementation that I've just done. I'll note that hard mode forced me to refactor my code because I had done it very simply, and hard mode made me really rethink things. I would love to see if someone do it as a web VI so we can all play it on the same. That would be kind of cool if we could all see it together. And just so you know, now there must be hundreds of different Wordle variations now, just as little trivia. You can do different word lengths. There's duodle, quartal, and octordle, where you can do 2, 4, 8 words at a time. I like to do nerdle because it's mathy. Hurdle shows little snippets of music. World is geography and you guess countries. And then Purtle is name the basketball player, which I'm into basketball. So anyway, that's the coding challenge, and try to do Wordle or something else in LabVIEW, and I think that'll be kind of fun, and we'll share solutions at the next one.
Awesome.
Questions? Thoughts?
Well, it's kind of interesting that this is basically Mastermind, but with
words,
letters.
yeah. Mm-hmm.
And yet it took, half a century for someone to think of doing it with something else. And of course, once they introduce that idea, then of course there's thousands of.
There is a board game this is similar to, though I had never heard of it. I've only thought of it as Mastermind.
The creators of that board game are really angry.
Yeah.
They wish they knew how to program.
Yeah. Awesome. All right. So we will be sending out an email telling everybody when Q2's meeting is, or we can look that up actually and announce that as well at the end here. So this challenge will be for Q2 of this year. And so, or as we could also say, our next meeting. So if you want to participate, feel free to just jump in and do it. Like Jomar said, you can do it exactly as the game is. You can spruce it up, do it however you want, get creative, use different words. Don't use words, use math, use another method, visualize it differently, right? Have fun with it. That's the whole point. And then we'll just be really excited to see what everybody comes up with. So cool. All right. If there are no more questions about the coding challenge, then we'll hand it off to Eric.
Awesome. I'm looking forward to the coding challenge.
And Sam, feel free to join us next time and participate in the coding challenge too if you want.
He'll show a completely unit tested version.
Yeah.
All right. So the VI that I'm going to show is, so at our company, we use a lot of the Atlassian tools. So we end up using Jira. And I thought that there's got to be a way, and was pretty certain that there was a way that we could post Jira or post have a way that on deployed systems that people could, click and request features or report bugs in a way that we could see in Jira. So I went in and I did the work to figure it out, and it turned out to not be that complicated. You just kind of had to know where to look and which things to find. And so that's what I've put together here. I actually already posted to the users group website the code along with this PDF that kind of walks you through the steps on how to do it, because you have to set up a separate token, an API token, so that you don't have to save passwords, and those tokens can be revoked at any time if you decide you don't want that token to be used, and then there's you also have to have a curl installed, which is I don't know that much about the application, but it kind of packages things up to be sent over the internet in order to be. And actually, this VI just calls the command line, and so this kind of shows how to set it up and kind of what you end up getting. But the important part is that you end up with a string that you create that you then that is used as part of the command line, and that gets implemented, at least the way I did it, this way. So there's plates for the address, the headers, the information that you need to create your issue, and then your user info, so your username and the token. And so when you run that, or let me go first prove that, so this is my Jira project. And if I go run my test VI, which calls that the VI that we saw before, I should get an issue that has a summary of a test summary, and then a bunch of information. And if I refresh, there's my new issue. And if you want it, you can make issues, and you can do enhancement requests, and all kinds of anything that Jira has available you can do. But and I walk through it in this PDF, because you have to go in and figure out like what the different issue type numbers are, which I think is further down here. In any event, in order to give other people time, I posted it so that, and if anybody has any questions, I'm happy to answer them. All right, hearing no questions.
I definitely recommend using Jira if you don't already have an issue tracking method. It's really convenient for tracking requirements, enhancements, bugs, and everything like Eric mentioned. And yeah, now it's super easy to plug into your LabVIEW program so that people can actually report bugs and enhancements and so on from within your software. So it's pretty cool.
Yeah, without having to have any passwords either, which is the nice thing.
Yeah, they don't have to log in.
Yeah.
Cool. Thanks, Eric. All right. I think we said Tom was going to be next.
Alrighty. Well, all right, everybody see my screen?
Yeah.
Okay, great. So yeah, I just have a simple little thing here. This was how to do in this case, a two-dimensional sort. But the technique for sorting is, you might find, and you could apply it to other things as well. So this is just a simple, I'll just choose a column and sort. And in this case, it's like a two-dimensional, let's say an address book or something like that. But this is a technique, it's a lot faster than the built-in two-dimensional sorting that the LabVIEW is now including. And all I'm doing here is simply choosing the column and then adding that as the first element into a cluster, or building a cluster with that first column, and then the whole array as a second element of the cluster, and then sorting that cluster, and then taking that and pulling off that array back off of that cluster. So by doing that, I can just choose any column I want and sort it. It's like if I want to sort by the second column, it'll sort that way. So it's just nothing terribly complicated here, but just discovering this little technique of being able to sort a cluster, an array of clusters, ended up being rather powerful.
Yeah, that's great. I don't think a lot of people know that you can sort based on the elements in a cluster like that.
So that's all I had. Very, very short. So
just a point there. If you were to save that as .vim, then you could reuse that on just about any type of data that you wanted.
yeah, so you can do
Just
that.
FYI.
Yep. Good point.
Yeah.
Cool. All right. Thanks a lot, Tom.
Sure.
All right. Steve's turn. There he is.
Trying to make a dramatic entry here. Okay. I will move my meeting here so that I don't get a house of mirrors or whatever. And then see if I can share the right entire screen. I wonder if it's going to assume the right. Oh, I see I have a choice. Okay. So I wonder if I can move this. Yeah, I can move this thing out of the way too. Cool. All right. So you should be seeing 3 front panels, right?
Yep.
Okay, cool. So in order the other 2 on the right, we're just going to look at this one first. I suppose I could, I'll make it really easy to ignore them. So the general idea is for a queue message handler, it started real simple where I just wanted to get rid of all the references that get wired all over the place for the queues. And so I used an action engine to store them. And then I kept thinking of more functionality I wanted to add. As long as this thing was, using queues, it was pretty much impossible to write a unit test for it anyway. So I might as well just make it more complicated, right? I'm kidding somewhat, but anyway. So one of the things I have with my action engines is I use a standard action that, maybe implement all the actions in it, maybe you don't, but it's got a lot of the things you'd want to do, like a knit. And I like having an idle, but that's another discussion. Get, put, read, write, on, off, and quit are kind of the most common things I can think of. And maybe you have to kind of use a liberal definition of these words. But the advantage of using the exact same action for all your action engines is that you can have a situation, maybe you want to quit, and you want to quit 6 different action engines, and you can just wire the same, action to all 6 of them. You don't have to have a separate, constant for each one because it's a different definition, whatever. This you need to customize for your application. It's a list of every loop in your application. So in this case, we have state, wait, DAC, and error, but you could have 50 different modules, and you add them all to the list, and you add them before these last 3, which are kind of special, and I'll talk about them in a minute. But as long as you customize this to your application, then this same VI would work in any application basically. So as outputs, I have a start ref, and which I'll again explain in a minute. Well, actually, that's kind of beyond the scope of this talk. But anyway, there's a quit boolean, and then a reference and an array of references. And the idea is, well, I'll go into the code here. So when you initialize it, it takes the list of the possible loops you can go to, talk to, and it counts. It takes the number of units and it subtracts 3 because of those 3 special ones that aren't actually loop names, and then it just goes through and generates references for those loops. And then it stores them in shift registers. This is standard, action engine here. I also have the start reference that gets created and stored. Okay, so then the normal case is that you're asking it to get a reference to a queue. So you say, I want the reference to this queue. It pulls it out of the array of references it has, and puts it out as the well, actually, it puts it out here as a single queue. You also get an array of the queues, but it still only has the one element. And the reason we have this is because if what you choose 2 to be is all, then it just wires the whole array through, and you get the first one, which is state, which is the most common one you'd want to talk to anyway. And but then you get the whole array, and that'd be useful for things like you want to do something, you want to send a message to all the queues, like quit or whatever, and you could just get the array and then just stick it in a loop and do whatever you wanted to do to all the queues. The quit is triggered by the quit state. So when you get the quit state, it closes out all the queues. I mean, this nice, clean code here, get rid of your references. And then only after the references are all gone, then it puts out a quit signal. And it gets rid of the reference too, of course. And in each loop, you're typically doing, so in every loop, you can wire this quit to the stop sign. And quitting a multiple loop, parallel loop program is tricky, to put it nicely. I've tried like 8 different ways, and every one of them has disadvantages, to say the least. But this at least is a way that you can just wire the output of this in every single loop to your stop sign, and then it'll only quit the loops once all the queues are taken care of, which has its own issues too, but there's ways around that. Anyway, so that's what that's for. Any questions on the action engine for queues? Okay. Now here's 2 uses of a queue action engine. The one is to write something to a queue. Now, again, this is kind of grown in functionality, so it's got quite a few inputs. A common and really useful structure for queues for the actual data is just a string and a variant. And then that way your string tells it what state to go to, and in that state, it knows what data it's expecting, and so it knows how to decode the variant. And it's totally flexible now. You can send any kind of message from anywhere to any other place. But what I found was that a very high percentage of the time in applications, the only thing I'm sending is a Boolean. I'm done, I'm ready, I'm, whatever, I failed, whatever. Or sometimes I'm sending, that's the main thing, it's a Boolean. And so what I do is I just have a Boolean also as part of the structure. It's kind of redundant. You could put it in a variant, but why sit there coding to and from a variant every time that all you're trying to do is pass a simple, Boolean? So I have that in here. The other thing I've added is something called reply, and then reply to is the same loop control. So what you can do is you can send a message, like the state machine can send a message to the DAC module and say quit, and the DAC module then cleans up its act, closes its tasks, does all the nice things it's supposed to. But how does the state machine know how long it took the DAC module to shut down and that it successfully did so? So what it does is when it tells the DAC module to shut down, it says, and reply to me with that you did it. So you can put a reply to of state, and then the reply message is quit successful or something like that. And now you have a state in your state machine that says quit successful, and that processes whatever it has to do after the DAC engine shuts down. So that's one example. Or you could say maybe you have a motor module or position module basically, and you tell it go to 13.7 centimeters. Well, you don't want to just sit there waiting for it to do that. You go off and do your other things, and you're reacting to user interface and this and that. And eventually it does a reply to state, I'm there, I'm done moving. So that's what the reply is about. And so I have, again, this could be a lot simpler. You could just have the data in the string, but I've got the reply to, and I also send an information about where it's from. That could be useful. Maybe you have a generic, well, one of the things I do is that I'll shut down all the modules. I'll tell all the modules to quit, and each one responds with they're done quitting. And then I just have one state in the state machine that has an array of booleans that are all set to false to start the program. And then as each module reports back that it's done quitting, shutting down, then I set that boolean and I wait until they're all true, and then I know that all the modules have shut down. Well, how do you know which one is reporting that they quit? Well, that's why I have the from. So you can set the from as, again, just a loop control, that loop list. And that way, then the state knows who it is that's reporting that they're done. If you didn't do it that way, you'd have to have a separate state for each possible module that would reply. And that's just, that's a lot of extra code for no reason. Anyway, so if I say none as my input, that was one of the special cases in the loop, none, then this thing won't be an empty array. When it's an empty array, then it just knows not to do anything, right? So, but otherwise it could be one loop or many, depending on what you told it to do here with the two. In whichever case, it's going to go ahead and do the, put the things on the queue. And then I found it useful to have a Boolean front, and that enqueues in the front of the queue instead. And that's really useful for like quit or error or critical error or whatever. You set your front to true, and then it puts it in the front of the queue, and it's going to be the first thing that the receiver gets. I also added a feature where you could say maybe after you send the message you want to wait half a second for some reason or whatever, then you can put in a wait function here, but that's again kind of optional. So any questions on the write queue function? It's your last chance before you get to read queue, which is a bit more complicated.
I was just curious if you run into any performance issues or anything with that VI needing to go through so many different steps in order to send messages?
I never have. Something I've been kind of on my bucket list or whatever to-do list is to do some kind of benchmark on how fast you can send messages. Just in general with queues, both the number of messages that you can send, and then also this, the amount of data, the bandwidth of those messages, if they're, and figure out what the limits are. So many big megabytes per second can be transmitted, or so many messages per second can be transmitted. And I suppose as part of that benchmark, I should, see what the difference is with these VIs, but I don't think it would really be that bad. I mean, really, when you tell it what loop you want, it's just doing a single, well, I'll go over here. It just does a single array, operation to pull a subset of the array. And then here, I mean, the for loop is going to execute once because it has a one element. And that's about all it's doing. So I'm not sure I'm adding much here. I don't think I am.
Okay.
I mean, it's a valid concern.
Yeah.
Anytime you add abstraction layer, you're adding inefficiency, right?
Sure.
How many loops have you tried this with
What's the maximum length of the number of loops? I know what you're asking.
Yeah.
Okay. Probably on the order of a dozen.
Okay.
We had a system we did where it had hydraulics, pneumatics, a power supply, a motor, a linear measurement of location, and every one of those was a separate module. And we had so many PID loops in the system that we had another module that all it was for is for let the user tune the PID loops. And all of these things had loops in them, and so it ended up being quite a few, in addition to the user interface course and state machine and all that. So why are you thinking that if it was a lot of loops that it'd be a problem, or just that this is maybe overkill if it's only going to be a couple loops?
Well, I was just thinking that in order for that to work as a functional global variable, right, it has to be non-reentrant. And so if you had enough loops, that might be a bottleneck.
Oh, sure. I see what you're saying. In terms of it blocking. Yeah. That's valid. Again, it gets back to the performance issue. And that'd be something to watch for. Definitely.
Are most of your processes single loop processes? Or do you use multiple loops?
Guess I'm not sure how to answer that. Typically, all the loops are running simultaneously, but any given loop is, typically have 100 millisecond wait in it or 10 millisecond wait or something, and that's loads of time in a computer, right? So,
I think kind of what you were getting at, Will, is like how many parallel loops within the same module.
Yeah, that's a good way of saying it.
3 is the most I typically ever do. I think I've had 4 once, but normally 3, and that'd be the top level VI. And then normally the modules are 1 loop each, pretty much. I had one exception to that where I had two exceptions in one project where I had 2 loops in each of 2 modules, but that was pretty rare.
Okay, so you enqueue messages directly into each one of those. You don't have anything that goes in between them that manages what you're asking your modules to do?
Well, the thing about it is you can go from any loop to any loop in here. So I could go within a module or between modules. It's not good coding practice to be having your modules talk to each other directly, but you could if you had to, or maybe it's a rare exception. But the situation.
So,
go ahead.
I was going to say, do you find it difficult to debug since any module can then talk to any module, or is that?
Well, that's why you want to avoid that. Exactly. That's why you don't want to do that. It's not good practice. But the state machine can talk to any module, and the module can talk back. But the thing is, if you have 2 loops within a module, you have the ability to just have the one loop talk to the other loop if you want to. One of the situations I had was a DAC module that also had to do some file I/O occasionally, and it would just offload that to another loop so that the file I/O wasn't, causing the buffers to overflow. Anyway, any other questions? There's good feedback, good questions. If I ever do the benchmark, I'll report back what I found out.
Sounds good.
Okay. So then the read gets a little more complicated. Actually, a lot of this is debug/tuning code, like all of this down here is. It's and this display right here, it's just constantly tabulating how many things you have in each queue. So it's a way to pinpoint if you've got some kind of bottleneck in your program or something. You wouldn't have to have that, and that's done right here. So this, a lot of the reason for this right here is for debug. So if I retain values, talk about slowing down the code. If I retain values, and I want to see what's going on, something really weird going on with my queues, I can come in here and look at the array of all the various. This is dumping all the messages on the queue, and I can look at, and this is in an array, so that I can look at all the queues, all the messages in all the queues at any time with my probe tool. And obviously that's going to have a serious performance hit too. And so you could you could throw all this out and not use it. I suppose I could have it in a diagram disable structure, but again, usually I'm not really. I guess I normally architect systems so that they're not having to pass millions of messages per second or anything like that. If you do it right, if you have your modules doing their one function and they're doing all of that function, I mean, that's really ideal, right? They don't really have to talk to anybody hardly at all. And, and you do things like do your averaging and your selection of data points and so forth in the DAC module. So it's only passing summary statistics out to anything else that's going to maybe graph it or something like that. You don't pass all the raw data out of your DAC module. You got to use some sensibilities to help with performance. Anyway, so these call the reference engine. So now you don't even have to put the reference action engine down anywhere. You're just putting the reads and writes in your loops, which you have to put something there anyway. So what the added complexity of the read, and actually I gave a talk on this, I don't know, a few user groups ago about the whole state machine conundrum of, if you want a state machine that when it does A, it always does B and C, and you just put that in your shift register, you come around, you do it as the next state. But in the meantime, the DAC module comes in and says, I need you to do X. Then how do you handle that? Do you do B and C first and then do X, or do you do X and then try to come back and do B and C? This, I won't go through all the details, but the logic here lets you basically specify what you want to do in that case. And you can even make it, programmed specific. But the string is coming from the shift register of what the last state said you should go to at the next state. If you leave that blank, then it knows to just ignore that aspect of it. Now it's just going to use the queue. But the problem is, if you just do the queue and then you do that next state, now you've lost what state the state machine was asking you to go to next. So what I do in that case is I put that back on the queue. So in my case of the A, B, C, and X, I do A. It's supposed to do B next. The X interrupts, so it'll do X, but it puts B on the queue. It was in the shift register, now puts it in the queue, so it's still going to come back and do it. So that's how I solved that. Anyway, like I said, I don't think you want me to go through all the logic of how it does all that, but I differentiate between if it's a blank string or not in terms of how it handles it, so forth. And there's a Boolean somewhere, toss string. So that says if you can't do the string, just throw it away. Don't even bother putting it in the queue. It's optional kind of thing. Maybe it's the idle case that all it does is update some indicator. And you just say, well, skip it this time. We'll just get it next time, kind of thing, or whatever. So, any questions on this or the other ones? Then you got your reply out and the reply to, and in a module you might have normally I have like one data structure that's got a structure that's got all the information that module needs to know. And then in there, I'll put in reply to and a reply string. And whenever I read something, the first thing I do is I update that reply to and reply string. and then the code looks at it and periodically and says, if it's a blank string, you don't have to reply to anybody. But if there's something in that string, then you have to reply. And now you know where to reply because you can look up the reply too. So that's a mechanism where you install that in all your modules, and then they all have the capability of replying as requested.
Hey, Steve, we got a question from Pavan. Do you get into any recursive issues with this?
Recursive issues. No, not that I can think of. I mean, yes, I suppose you could pathologically. Well, with any state machine, you could have A goes to B and then B goes to A, and and that could be a problem. But that's a state machine design issue. It's not an issue with the queues. I guess I don't. I'm not. Maybe I missed the. Maybe I missed the avenue of having recursion.
We can't hear you.
We can't hear you.
All right. Yeah, I still can't. And now you're muted. We'll speak for you.
Well, I can follow up with them too. I'll follow up with them. That's
I think
fine.
he's typing.
He's probably typing in the chat, huh?
Also, I'm sorry if I mispronounced your name. I know.
Vaughn's correct. Oh, okay. So he's saying that one QA talks to QB and then Q for reply, and then QB says reply back to me. Okay, sure, that could happen, but again, you just design it so it doesn't. When you do the write, you don't have to put anything in reply string. If you leave it blank, then the other queue won't respond. The other loop won't respond. So the default is not to respond. You have to actually tell it to respond explicitly, and then it will. So yes, if they each have that reminds me of something that someone did with Alexa. I guess it was they had two of them, and then they had them each put the other one in a calendar. And anyway, it got to the point where they were talking to each other constantly about the fact that they were each had an appointment in the other one's calendar or whatever it was. But you just try not to do that unless you want the entertainment value of that. But and that wouldn't really be recursion. That's more of I guess an infinite loop in my mind. It's not really recursion, but yeah, I understand.
All right. I'm gonna. Hey, we heard that. I'm gonna say let's move on to Josh's, and then if we want to continue this discussion afterwards, we can do that.
Sure.
I think Sam had something he wanted to announce first.
Yes. Thank you, Josh.
Yeah, I just want to make a plug. I don't know if anybody here went to GDevCon NA in Denver last year, but we're doing it again this year. It is in July. It is, I want to say, the 18th and 19th and 20th or something like that. It's the middle of July. It's a Tuesday, Wednesday, Thursday. And the website's there. You can get tickets. And gdevconna.org. We're also looking for presenters and sponsors if anybody's interested. It's a 2.5-day conference, all kinds of presentations and social stuff going on. So.
What's the focus? Is it all LabVIEW? Is it NI? Is it?
It's all LabVIEW. Last year, NI was a sponsor. I don't know if they're going to sponsor this year or not. But it's pretty much independent from NI, other than the fact that last year they sponsored and they give a few presentations. But if you guys all put in presentations this year, then we cannot choose any NI presentations. So don't want to see NI get up and put in your presentations.
No,
so there's no marketing stuff for sure. So at iWeek, there's lots of NI marketing stuff. So we do not accept any of their marketing presentations. So even though they're a sponsor, their presentations we're not marketing presentations
Is-
so much.
There's no trade show, I take it.
We also no trade show booths or anything. It's basically like if you went to NI Week and went to the champion sessions, that's more or less what it is, except that you don't have to be a champion to present. So we've got a bunch of people presenting who are not champions. And we have a YouTube channel with all our presentations from last year that you guys can check out to give you an idea of what to expect. So I will throw that in
That's great.
the
Yeah, you got a link to it?
chat. Yep. I'm looking it up right now. I don't remember it off the top of my head. YouTube doesn't give you a nice fancy link unless you've got like thousands of subscribers.
Post the comments below.
There you go. What? Oh,
Steve, you can probably.
there's the YouTube channel.
Okay, so it's cold hard LabVIEW. You actually get technical content, and it's not marketing focused.
Yep. Zero marketing. I mean, we do have sponsors, and the sponsors get if you give us enough money, they get to stand up for like 5 or 10 minutes and say a little spiel, but that's it. So.
Awesome.
Yep.
Could you put a link to the conference, please?
What? A link to the conference?
Yes.
I did throw it in there, but I'll throw it in again.
Oh, sorry. No mind. I just saw it. Thanks.
Are you guys gonna
it's cool.
post the agenda?
It's not clicky. Yes, we are. Unfortunately, and I don't know. We're like a nonprofit. We have a board that runs it, and I try to get them to push things earlier, but we won't have an agenda until May 15th. So you can submit presentations up until April 30th. So you got about a month if you want to submit a presentation. I can tell you we've got presentations on a variety of things. There's a web one on like doing some web stuff. There's one on better user interfaces. There's one on actor framework. There's one on just general LabVIEW tips and tricks from Darren, which of course will be very good. There's a couple other ones. I think we've got 7 or 8 presentations already that have been submitted. So we've got room for some more. So. And hopefully, it depends on what we get submitted, but hopefully we hope to have a variety of things that are around. You can see the agenda from last year. You can look at the things Roland, that is from the one in Europe. So there's a gdevcon.com, which is the guys in Europe, and we are actually a separate organization, gdevconna.org in the U.S. We do the same thing, but just for legal reasons and everything else, we're like a separate entity. So I highly recommend going to the one in Europe too. If anybody really likes to travel, it's a great time. The last time I went there, they did it in somewhere in England, and I went and hung out and checked out a bunch of castles and stuff. It was really cool. So they're also really cool, but Denver's a little closer and cheaper. So no castles here, but.
And you're sure you're gonna make it home? They're not gonna lock you up in Europe, so.
Yeah, there is that too. Yeah, you don't gotta worry. Like if COVID outbreaks or something, you're not gonna get like stuck. You know, if they close the borders or anything crazy like that, or World War III breaks out or whatever. So.
Fingers crossed that won't be happening.
I do hear that there is going to be one in Europe this year. I think they're going to do it at CERN. So if you've got the money to travel, I would recommend going to CERN over coming to Denver. But that's me. I think CERN would be really cool at the risk of, cutting our attendance. So anyway, yeah, thank you. I thought I had a slide about that in my presentation, but I seem to have missed it. I skipped over it. So I'll make sure I upload for that.
Well, I heard really good things about it last year, so I definitely encourage people to go this year. I was not able to go last year, but yeah, we'll see.
And we are also looking for sponsors. So if anybody wants, you can get a sponsorship package. If anybody wants to talk about that, if they think their company might be interested, just send me an email. I will throw my email in there in case anybody wants to get a hold of me about anything. And you can find me. I'm also on like Twitter and LinkedIn and all that stuff. So. Yeah.
Awesome.
If you have any questions or whatever, let me know. All right. Thank you. I think I'm going to get going because it's getting late for me. But thank you, guys.
Cool. Thanks a lot, Sam. Really happy to have you.
Yep. Thank you. Yep. No, I was happy. I'll do it again anytime you want.
Awesome. Thanks.
Bye.
Bye. All right, Josh, bring it home.
Will
He's
do.
not there. There he is. Okay.
Sorry, I was just trying to get my second screen set up so that I could share better. All right. Entire screen. No, I can't do that. Okay. It says my browser can't share my screen.
What browser are you using?
Brave.
You want to switch over to Chrome?
Yeah, I'm in the process of switching over. Let's see.
In the meantime, I can announce that we're planning on the Q2 meeting to be June 1st. That's a Wednesday. So that's when we'll be doing the coding challenge Wordle solutions. And we'll be letting you know based on how the COVID situation is, whether or not we'll be able to have that in person or remotely. So
Will that be 4:30 to 6:30 also?
that will depend on if we're remote. I think previously when we weren't remote, we gave people a little bit more time to get there, and so I think we did 5 to 7 instead of 4:30 to 6:30. But we'll decide that sort of once we know exactly what's happening.
Have we found any sponsors yet?
No, we have not. NI has officially, everybody I've talked to at NI has said they do not have budget. So we don't have official sponsors. If people want to sponsor the user group and help pay for food, that's definitely going to be appreciated. And feel free to reach out to me about that. You can just reply to the user group emails. But I'm sure we'll come up with some solution. But if we have sponsors, it would just probably be on the order of a few $100s or something to feed people. That would be awesome and allow us to make it even better.
I'm also going to jump in and throw out if your company is open to hosting the event, since it will still be probably in this weird time, it's likely that things will change quickly as far as what companies are interested in having, whether they're interested in having people come from outside the organization. But if you know that your organization is willing to do that, feel free to let us know. And if you just send it to Will, he'll get it to me if you don't have my email.
Cool. Thanks, Eric. All right, Josh, you look like you're ready.
Yes, sir. All right, so I made a malleable VI that takes the derivative given a discrete array. And I say discrete array because it doesn't matter what dimension the array is, it'll still take the derivative, at least along one of the dimensions. Earlier I was going through trying to find the way to explain it. It takes the last dimension and takes a derivative in that direction. So if you have a single dimension, then it's just a normal derivative of a 1D array. And if you have a two-dimensional array, it takes the derivative in the y direction, right? So a single array would be only an x, and then if you have two dimensions, you have an x and then a y, which is the going vertically. And then if you went into higher dimensions, like 3 dimensions, you'd add a z, and then you'd keep going. And it takes a derivative in the last dimension, if you will.
So like a 2D array, that means like row 2 and row 1 are compared.
Yeah.
Right? Subtract row 1 from row 2 to find your difference. Is that right?
That's correct.
Cool.
If I just drop it on here. So it would take a derivative row 2 minus row 1. Right, so take a derivative of 3 minus 1, 2 minus 4, 6 minus 2, right? So it would, and then if you had more rows, each row would be subtracted from the previous row. Yeah. So this runs and it generates a sine graph. There's the sine function, and then it takes the derivative and outputs the derivative. And I guess to dig into the code a little, that opened up the other screen. So the discrete derivative, it's a really simple block diagram. As you can see, I take the array in, and then I remove the first element. For one-dimensional array, it's only a scalar that it removes, but in higher dimensions, it removes the first row or the first two-dimensional array of a 3D array. And then it takes the dimension that had the element removed from it, and it subtracts the original data. So effectively it does a derivative, which is really cool. It's something I used in my own personal project.
So your example with the array, where it takes row 2 minus row 1, I thought you said it would then take row 4 and row 3, but it's actually going to take 3 minus 2, right?
3 minus 2, right.
Okay, all right.
Right. But there's not a third row at the moment. So row is the horizontal, right? So 1, 4, 2 would be one row, and 3, 2, 6 would be one row. I think that's the hardest thing, is using the same words, but then we flip which one means which one. And then you can go in here, change it to cosine. There you can see it change appropriately. Made it so you can change the sample size. Yeah. And I guess I could show.
You do e to the x and see if it's right on top or not.
That's e to the x, right? Roughly.
I think it's 27138 or whatever.
Yeah, I rounded. Sorry. I didn't memorize that many digits. I did prepare beforehand. I was like, oh, someone will probably ask about e to the x, so I prepared specifically e to the x. Yeah. And I use this, I have like a image detection program that I've been developing, and so here you can see the kind of the original image, and then if I move over, you can see this is kind of using that derivative and then looking for zero crossing after you take the derivative. And what you're doing is an image is a two-dimensional array of pixels, and each pixel is represented by 3 components, red, green, blue. And so right there I have 3 different dimensions, and so I'm taking a 3-dimensional derivative along one of the axes to get that edge.
I did a code challenge a year or two ago that was edge detection. This would have been a good solution to that.
I did not have this ready in time for that. It's only more recent that I've been getting this to work. Part of it is I'm kind of wishy-washy on how I want to implement it. So I've been kind of exploring kind of the fringe of what's currently done. So there's a lot of edge detection methods. There's canny edge detection, there's Sobel edge detection, and then there's a canny Sobel edge detection. And then there's zero crossing is another form of edge detection. And a lot of my time has just been spent researching and trying to understand light better, because I feel like some of the issues stem from having kind of a minimalistic approach of like, oh, light's so simple. It's just, a color and brightness, but it's more complex than that is what I'm discovering.
You might also want to look at HSL instead of RGB if you haven't done that already, which is hue, saturation, and luminosity.
Yep. You can convert from RGB to HSL, and I've tried that, and I've decided to make my own conversion.
Fair enough.
It goes along the same lines of you have a color, you have a brightness, you have a saturation, right? Those are the same 3 parameters that most people think of. It's just how do you want to represent the brightness changes based on, is it luminance, right? Is it the actual energy output of light, or is it how the eye perceives the brightness of an image? So,
yeah, cool. That's pretty awesome picture in itself.
Yeah.
The edge detection version, yeah. Cool.
That's
All right.
what happens when you write code and don't write test cases for it.
Unit tests, yep. That's right.
Yeah.
Awesome. Cool. Thanks, Josh.
And I will stop sharing.
All right. So that concludes our user group for today. Thank you all for sticking around. We went quite a bit over time, but there was a lot of good content and a lot of good discussion. So once again, June 1st is when we're planning on having the next user group meeting, and we'll be sending out emails about that. Make sure to tackle the Wordle coding challenge. We're excited to see what people come back with. And you'll have an opportunity to present those solutions at the Q2 meeting. So with that, unless somebody else has any announcements, I'd say thanks again and have an excellent evening.
Okay, thanks, Will.
All right, have a good one. Thanks.